review for applications of differential calculus, and a lot of it is going to be based on analyzing graphs. Okay, so here you've been given the graph of derivative function. So the y values represent f prime. And it asks you find any local min-max inflection points. Okay, so where are we looking for mins and maxes? Well, we're looking for where f prime is equal to 0. Okay, so at x equals 0, we have a 0 here. At x equals 3, we have a 0 there. At x equals 5.5, we go there, we have a 0. And we want to know what's happening on either side. So this is an endpoint, so we're not going to, that's going to have to be something that we have to be careful of. It's going from, in this case, it's going from positive slope. Okay, sorry, it's all positive slope here. Okay, so in between those 2 points it's positive. Okay, here it's going to be negative slope all the way through there. Okay, and then again, once we hit that 5.5, we're back to positive slope. So it looks like this. So it looks like we have a max here at 3, a min at 5.5. Okay, so what about inflection points? These are local mins and maxes. So what about inflection points? Inflection points happen when the second derivative changes from positive to negative. Well, if this is the first derivative, we're looking for where the second derivative, or the slope, changes from positive to negative. So anytime you have a change of slope from positive to negative, although that's not a slope of 0, okay, we know that there's an change in inflection. So at x equals 1, on this side, we know the slope is positive, which means the concavity is positive. That is a non-differentiable point, but on this side, we end up with a negative slope or negative concavity. Okay, so that represents an inflection point. On the first derivative, when we go from positive to negative, or vertice, we end up with an inflection. So that means that there, we're going from negative slope to positive slope at x equals 5, although it's not differentiable. Okay, there's no derivative, second derivative at that point. We know it's going from negative concavity, or negative slope on the derivative graph, to positive slope on the derivative graph. So those are 2 points of inflection then. Okay, so what does a potential graph of this look like? Right, so if I was to sketch this, okay, so I have positive slope from 0, it's going up, and it's curving up. Okay, so it's going to be positive concavity like this. It hits 1. Okay, it's going to be negative concavity going up still all the way to 3. And we have a maximum point. There we're going to start going down. Okay, and at 5, it's still going to go down to 5.5, but it's going to have an inflection. There's our min at 5.5. Okay, so there's an inflection point. And then it's going to have a minimum, and then still concaving up. It's going to go up in this manner. So actually it stops at 6, doesn't it? Okay, so there's our endpoint at 6. Okay, so that's a potential graph of this function. Okay, so and again, I made a note here that although we don't need to have a second derivative 0 to have an inflection point, we just need to have a change of concavity. Alright, so here's another one. So same issue here. We have a second derivative graph, and we're asked to find positive, negative slope, max, mins, concave, up and down. Okay, well, if something is going to give us positive, negative slopes, we need to then look at where it's equal to 0. Okay, so at negative 3, we have 0 slope. It's going down because it's negative slope here. Okay, so or negative y coordinates, which means negative slope. Positive y coordinates here, so we have positive slope. Okay, it's not to do with the actual graph, it's to do with the y coordinates. all the way to x is 2. Okay, so it's going to be sloping up, and then we're going to have 0 slope, and again, it's below the x-axis, so we have negative slope. So there's our min and max. Okay, we have a min at -3, a max at +2. Okay, we're going to have regions of positive and negative slope, so there's my slope chart. And then we should do the concavity. Okay, so these are my max mins. Concavity, so f double prime, the green is f prime. Concavities are going to happen where the slope of the slope changes. So that's the only place where the slope goes from positive to negative. So at x equals 0, in fact we have 0, that's going to give us 0 second derivative. And then on this side we have positive slope, which means positive concavity. On this side we have negative concavity. So that 0, x is 0, is an inflection point. Okay, so this is an inflection. And those green zeros represent max and min. So this is a min. This happens to be a max. Okay, as we go through that way, we get minimums. We go through it, going from left to right down, we get a maximum.